All right, so let's continue to 2.6. The limit involved with infinite and the asymptote. So starting with one example here, we discussed the what is horizontal asymptote, what is vertical asymptote, right? So now let's look at one example here. Given the function fx equals 3x squared plus 4x plus 9 over x squared minus 1. And ask us to figure out what is the horizontal asymptote, what is the vertical asymptote. As we discussed before, the horizontal is take the limit as x goes to positive infinity or negative infinity for the given function. Okay, 3x squared plus 4x plus 9 over x squared minus 1. As you can see, guys, it's very easy to observe that we use the dominating term method, 3x squared over x squared, which gives us is the 3, right? So even you change this part into the negative infinity, this limit is just still 3. Hence, the horizontal asymptote is y equals 3. Okay? So, so bad drawing, okay? As you can see, this is y equals 3. How do we handle the vertical asymptote? Well, as we mentioned that there is a shortcut to handle this type of question, which set the denominator equals 0, which is x squared minus 1 equals 0. Solve for x equals negative 1 and 1. This gonna be the vertical asymptote for this given function. Okay. So this is this is x equals negative 1. This is x equals 1. Okay. So the process actually to find the horizontal and vertical asymptote is very straightforward. Okay. All right. Now let's introduce the last piece of the section 2.6. It's called the oblique asymptote. Okay. What it says is, if I have a rational function and the numerator, the degree of the numerator is 1 greater than the denominator. So what I do here is the previous example is x squared plus 4x plus 9 over x squared minus 1, right? So the degree are the same. Right now, I rewrite x squared into x cubed, such that you see the degree of the numerator is 1 degree greater than the denominator. Okay, and the graph for this function actually it becomes into this, guys. Okay, it becomes into this. You can see that again, very bad drawing. Okay, guys. So let me modify a little bit more. Something like this. They're gonna also have the two vertical asymptote, but there is no horizontal asymptote anymore. Okay, instead, what we have here, you can see that actually it's this dash. It's a straight line, right? But it's not horizontal. This dashed line, non-horizontal, the vertical line here. It's called the oblique asymptote. It only exists again when the numerator is 1 degree greater than the denominator for a rational form. Then very naturally the question is, how do we figure out the oblique asymptote? Well, the answer is you're going to use a technique you might learn from high school, long division. Okay, so what you do here is use the long division to calculate this rational expression. So x cubed plus 4x plus 9, here is x squared minus 1. Put an x here, you're going to have x cubed minus x, and then you do the difference This part cancel, 4x minus minus become 5x, and then plus 9. Okay, 9 is directly put it here. Since this degree is lower than this, then we're done. So after we do the long division, this can be rewritten as x plus 5x plus 9, the remainder, over x squared plus 1. Okay, as you can see, guys, after you finish the long division, if you let your x goes to infinity, okay, in other words, you take the limit like for this piece. Do you realize that? Let me write here. Limit as x goes to infinity, x plus 5x plus 9 over x squared minus 1. Do you see that actually when you let x goes to infinity, this part, it's gonna become 0. So this x is the only survivor term. And correspondingly, let y equal x, which is the survivor part, that's gonna be the oblique asymptote. And that's how do we figure it out, okay? I'm not quite sure if I'm gonna give you a problem like this related to the oblique asymptote for the test or the final, but you know, it's definitely something good to know, you know, under this specific condition, and we know that the function has a oblique asymptote, and how do we handle that? Use the long division first, and then take the limit, and then get a survivor, and then let y equal the survivor. That's gonna be this oblique asymptote. Okay, so this is the end of chapter 2. You know, we finished all of this, and I hope you enjoyed this video, and I'll see you in chapter 3. Okay, bye.